7.4, we're going to talk about inverse trig functions. Let's do a little review first. Back in Math 1411, you studied inverse functions in general. What do you remember about inverse functions? You enjoyed them very much, that's correct.
No.
What else do you remember?
You have to replace the y with the x value and then solve for y.
Alright, so the big thing, inverse functions interchange input and output. And you said we switch the x and the y. X is usually the input, y is usually the output. And you're absolutely right. That's the big thing that inverse functions do. They interchange the x's and the y's, interchange the inputs with the outputs. What else do you remember about inverse functions? What does it mean to be an inverse function? So, definition. F of x and g of x are inverses if two things have to happen. The first one, you do f composed with g. And what do you get? That's the same as f of g of x. And when you simplify it all down, you get something very nice. X. Simplifies down to be x. And then you switch order. You do g o f of x. That's the same as g of f of x. And once again, you should get x. And we saw back in Math 1411, well, I wasn't there, but whoever taught you back in Math 1411 showed you that sometimes when you switch order with f and g, and you do FOG and you do GOF, you usually get different answers. So to be an inverse means you have to be able to do FOG and GOF and get x both times. Alright, so I'm going to make up a function here. How about f of x is 2x plus 3? What's the inverse of 2x plus 3? X minus 3 over 2. That seems like an excellent guess. Why does that seem like an excellent guess? Well, what's the opposite of adding 3? The opposite of adding 3 is subtracting 3. And what's the opposite of multiplying by 2? Dividing by 2. So that seems like an excellent guess. Is it the right answer? Well, how do you find out? Well, there's two ways. I think the easy way in this problem is we do FOG. And when we do FOG, what had we better get? We better get the letter x. So what does FOG mean to do? I take the g and I plug it in to the x. So I'm going to have 2 times x minus 3 over 2 plus 3. We simplify and we get well, that 2 reduces with that 2. And then that 3 reduces with that 3, and we're left with x. So are they inverses? Maybe. Why do I say maybe? You've got to switch the order. Sometimes when you switch order, you get different answers. All right, so we have to do GOF also. When we do GOF, I take the f this time and I plug it in for the g. So I'm going to have 2x plus 3 minus 3 all divided by 2. You take that and you simplify. What do you get? X, because this 3 reduces with that 3, the 2 reduces with 2, and you do get X. So are those inverses? Absolutely, those are inverses. I'm going to take the function f of x and I'm going to plug a couple numbers into it. Well, give me some numbers that you like for x. Anybody got some favorite numbers? 4, 10, 0. You always pick 0. 0 is always your favorite number. All right, so when I plug 4 in, what's 2 times 4? 8 and 3 makes 11. Plug 10 in, that's 20 plus 3, that's 23. And I plug 0 in, I get 3. Now I'm going to do the same thing for g of x. I'm going to pick 3 of my favorite numbers in the whole wide world, and I'm going to plug them in. What are your 3 favorite numbers in the whole wide world? No.
-1.
No.
0.
No.
4.
Your favorite numbers in the whole wide world are 11, 23, and 3. Why are those your favorite numbers in the whole wide world? What does the inverse do?
Oh, just switch it.
It switches the x's with the y's. So if I pick my x's to be 11, 23, and 3, I don't have to do any work at all. My answers are 4, 10, and 0. Let's just check to make sure that that really is true. Let's plug in 3 first. What's 3 minus 3? 0 divided by 2 is 0. Let's try one more. How about 23? 23 minus 3? 20 divided by 2? 10. So the inverse switches the x's with the y's. F of x is x squared. What's the inverse of x squared?
Square root of x.
Square root of x. All right, so if I do FOG of x, what would that be? X, because I would start with g, that would be square root of x, and then I square it. What happens when I take a square root and I square it?
Get rid of the square root.
I get rid of the square root and I'm left with x. Okay? What happens if I take GOF of x? That means I start with a square, that's x squared, and I square it. X actually absolute value of x. Some of you look like you don't believe me. All right, pick your favorite positive number in the whole wide world. 1. What happens when you take 1 and you square it? What's 1 squared? 1, and then you do square root. Square root of 1 is 1. So if I plug in a positive number like 1, I got 1 back again, didn't I? Now pick your favorite negative number in the whole wide world. Negative 1. What happens when you take negative 1 and you square it? You get positive 1, and then you take the square root of 1, you get 1. So if I start with a positive number, it gives me the positive number. But if I start with a negative number, it gave me the positive number back again. Isn't that absolute value? So are those two functions inverses? No, they are not. Why not? I was always told that squaring and square rooting are opposites. How come those are not inverses? I can't have absolute value. That had to come out to be just the letter x. That's right. So what's the problem? I put a negative in. I'm not allowed to use negative numbers today? I want to use negative numbers. I like negative. What's the problem? The square root of x squared is not a function. The square root of x squared, the inverse of x squared is not a function. That is an absolutely correct answer. The problem is, what does the graph of x squared look like? It's a parabola. It looks like this, right? So it has points like 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. What happens if I take these points and I just simply switch the x numbers with the y numbers? Well, this one's easy. If I take 0, 0 and I switch the x and y, I still have 0, 0. If I take 1, 1 and I switch the x and y, I still have 1, 1. Switch this one, 4, 2. Switch this one. It's going to be 1, -1, which is here. And this one's going to be 4, -2. So you end up with a sideways parabola. And that is not a function. How come that is not a function? It doesn't pass the vertical line test. Okay, so back in section 5.1 in Math 1411, there was a rule. And there was a rule that said a function has an inverse only when that function is 1 to 1. Does anybody remember what 1 to 1 means?
Does it mean it passes the vertical and the horizontal?
It passes the vertical line test and the horizontal line test. So look at y equals x squared. Y equals x squared certainly passes the vertical line test. It does not pass the horizontal line test. So does it have an inverse? No. So that was a trick question when I asked you what's the inverse of x squared. The right answer was? There is none. It was a trick question. Everybody always falls for that trick, by the way. Everybody always says square root of x. Always, always, always. So what did we have to do? What we had to do is we had to go f of x equals x squared. And somebody was right. Somebody said you used the negative numbers and that was the problem. You're absolutely right. What we have to do is say, I can only use the positive numbers. If I only use the positive numbers and 0, then I'm only picking the right-hand side of this parabola. If I only pick the right-hand side of that parabola, does it now pass the horizontal line test? Yes. So will it have an inverse? Yes. It's inverse. Square root of x. Yeah, now you're all gun shy about saying square root of x, aren't you? It is square root of x. Okay, so a function has an inverse only when it is 1 to 1. In other words, passes the horizontal line test. Well, to be a function, it has to pass the first test, yes. So if I say a function, then that implies that it already passes the vertical line test. But you're right, it would have to pass both. All right, well that brings us to trig functions. Here's my favorite trig function, or one of them anyway. This is the graph of y equals sine x. What's the inverse of y equals sine x? There isn't one. Excellent. Why is there not an inverse for sine x?
It can't pass both vertical and horizontal.
It does not pass both the vertical line test and the horizontal line test. It certainly fails the horizontal line test, doesn't it? If I draw a horizontal line, how many times will a horizontal line cross the sine graph? Well, in this picture, it crosses it 1, 2, 3, 4 times, but of course the sine graph keeps going and going. It's going to cross it an infinite number of times. All right, so if we want to talk about inverse sine, we need to limit our domain to make our function be 1 to 1. How would you limit your domain? Negative pi over 2 to pi over 2 is an excellent choice. Why negative pi over 2 to pi over 2? If I go from negative pi over 2 to pi over 2, it certainly crosses the horizontal line test. And that gives me all the values, doesn't it? I go from a low of negative 1 up to a high of positive 1. So that's exactly what we want to do. All right, so I want f of x equals sine of x, and I need to limit x to go from minus pi over 2 to pi over 2. Between negative pi over 2 and pi over 2, sine of x will be 1 to 1, and it catches all of its values from negative 1 to 1. All right, so if I have that, I can then talk about its inverse. And we have a couple different symbols that we use for sine inverse. Sometimes you see this one. I'm not a big fan of that symbol. Why am I not a big fan of that symbol? It looks like cosecant, but it's not cosecant. If I want cosecant, I actually have to write it this way. But I agree, that's very confusing, and that's why I don't like that symbol. So I prefer this symbol. If I'm using inverse trig functions, it's quite often called arc sine. So I prefer that symbol for the sine inverse. All right, I'm going to build myself a little table here. Give me some of your favorite numbers for x in the whole wide world that you would want to plug in. 1. 0 I like. What's the sign of 0? Sign of 0 is 0. I don't think I like plugging in x equals 1 very much. Do I know what the sign of 1 is? I can't use I can't use degrees. Pi over 6 would be a nice angle. What's the sign of pi over 6? That would be 1/2. And maybe one more. Pi over 2. What's the sign of pi over 2? It is 1. All right, so what I want you to notice, if I'm using sine of x, I'm plugging in what? What would you call these things? The radian measures of what? These are angles. So when I'm dealing with sine, I plug in angles. What kind of answers do I get? Regular old numbers, right?
Yeah.
0, 1/2, 1, those are regular old numbers. When I'm using sine inverse, what's going to happen?
You get numbers, like regular numbers, and then you get radian.
My input is regular old numbers. My inputs are things like 0, 1/2, and 1. My inputs are regular old numbers. What are my outputs? What kind of answers does it give me? It gives me angles. So if I plug 0 into sine inverse, I get 0, but that's really the angle 0. And when I plug 1/2 into sine inverse, I get the angle pi over 6, which happens to be 30 degrees, that's correct. And when I plug in 1 into sine inverse, I get the angle pi over 2, which happens to be 90 degrees. When I'm using sine inverse, what kind of regular old numbers can I plug in? Can I plug in 2? Why does it have to be between -1 and 1? All right, so when I'm dealing with my regular old sine function, my y values on my regular old sine function are between -1 and 1. So when I'm dealing with arc sine, what kind of numbers can I plug in? Only numbers between -1 and 1. How come? What does the inverse do with the x's and the y's? It switches them. So for regular old sine, the y numbers that I get are between -1 and 1, which means when I'm dealing with arc sine, the numbers that I can plug in are only numbers between -1 and 1. And what kind of answers am I going to get? I'm going to get angles, and those angles will be where? Between -pi/2 and pi/2. Questions on that? All right, going back to the computer. Here's my next favorite trig function. My next favorite trig function happens to be cosine of x. What's the inverse of cosine of x? It does not have one. Very good. You learned that trick question. It does not have one because it certainly fails the horizontal line test, fails it very badly. We can draw horizontal lines that cross an infinite number of times. How would you limit your domain to make 0 to pi? Why wouldn't you use -pi/2 to pi/2? It still won't pass the horizontal line test. If I use -pi/2 to pi/2, it still would not. So this time we're going to use between 0 and pi.
Could you use -pi to 1 as well?
I could use -pi to 0. Absolutely, I could. The traditional way is we use 0 to pi because we like picking positive angles more than we like picking negative angles. That's really the only reason. There's absolutely no other reason why you couldn't go -pi to 0. By the same token, there's absolutely no reason why you couldn't go from pi to 2 pi. You can pick any interval you want as long as it's all 1 to 1. We pick the easiest one. And for us, usually the easiest one is between 0 and pi, because between 0 and 2 pi, those are all things in quadrant 1, and we really like it when we can use quadrant 1. The same with the sine function. We didn't have to go -pi/2 to pi/2. We could have picked different intervals, but again, 0 to pi/2, that has our angles in quadrant 1, and we like quadrant 1. So. All right, but the point is, the domain and the range are going to be different. All right, so if I have f of x equals cosine x, I have to use my domain to be between 0 and pi. I don't have to, but that's the easiest one to use. What would my range be? What kind of y numbers do you get out of cosine? What's the biggest possible value for cosine?
1.
And the smallest possible value for cosine? -1. So once again, my y numbers for cosine are going to be between -1 and 1. So now when I talk about the inverse, again, there are 2 symbols. And again, I prefer the arc cosine symbol myself. What kind of x numbers can I plug into arc cosine? The x numbers are now going to be between -1 and 1 because they're the y numbers over here. We switch inputs and outputs. So for arc cosine, I plug in regular old numbers that are in between -1 and 1. And what kind of answers am I going to get? I'm going to get angles that are between 0 and pi. You're exactly right. Okay. So now I have a whole bunch of little questions here. What is the arc cosine of the square root of 2 over 2?
Or
45 degrees is a correct answer, except we will never give our answers in degrees.
5 over 4.
We will write it as pi over 4. Why is it pi over 4?
That's root 2 over 2 is.
Because this is the same as saying cosine of what would give me root 2 over 2, and the answer is pi over 4. That's correct. All right, how about the arc sine of square root of 3 over 2? Again, what I'm really asking you is sine of what
5 over 6.
gives you square root of 3 over 2, and you're telling me the answer is? Oh, I hear consent or dissent. It's pi over 3. She says it with great confidence. I'm going to go with her answer, pi over 3. Also happens to be the correct answer, so we'll go with that. Pi over 3. How about the arc sine of negative 1/2? So what I'm asking you is sine of what will give you an answer of negative 1/2? Okay, let's ask a slightly easier question. What if I didn't have that minus sign in there? What's the arc sine of positive 1/2? Pi over 6. So what's that negative sign going to force us to do?
Different quadrant.
Different quadrant. Excellent. Which quadrant?
3 or 4.
3 or 4. Except remember, we said when we're dealing with arc sine, our answers have to be between minus pi over 2 and positive pi over 2. So which quadrant are we going to be in? Quadrant 4, because negative pi over 2 to 0 would be quadrant 4. So I need you to give me an answer in quadrant 4. 11 pi over 6 is a correct answer. However, it's not written in the right form because my answer has to be between negative pi over 2 and 0. You're making it too hard. If this was a positive 1/2, the answer you told me was? If this is a negative 1/2, the answer is? The answer in quadrant 4 is simply negative pi over 6. Negative pi over 6. All right, let's do another one of those. Arc sine of negative square root of 2 over 2. Michael.
Good question though. Isn't this like the same as taking like second sine or second cosine of the calculator?
Yeah, it is. Look at that. There's a sine inverse button on my calculator. Look at that. So you're telling me I could do sine inverse of negative 1/2 on my calculator?
You could do a fraction.
No,
I mean, like a decimal.
it's not going to give you pi over 6.
It will not give me pi over 6, unfortunately.
But that is just from the decimal form, isn't
It is negative pi over 6 in decimal form, I think. Well, it better be. Negative, whoops, not e, I want a negative pi over 6. Hey, look at that, it is the same answer. Yeah. All right. How about the arc sine of negative square root of 2 over 2? Negative pi over 4, excellent. Negative pi over 4. How about the arc cosine of negative square root of 2 over 2? Negative pi over 4 is what a lot of people will say. Unfortunately, when I'm dealing with arc cosine, where do my answers have to live? In quadrants 1 and 2. Cosine is not negative in quadrant number 4. So since this is a negative, my answer better be in quadrant number 2. So without the negative sign, the answer would be pi over 4. What's the angle in quadrant 2 that has pi over 4 as a reference angle? 3 pi over 4 is the correct answer. So what you're going to have to do here is convert to the second quadrant. And the way you convert to the second quadrant is you take pi minus your reference angle. So that will be 3 pi over 4. How about the arc cosine of negative 1/2? I begin by noticing this is a negative, which tells me my answer is going to be in quadrant 2. So it's going to be pi minus something. If I take the negative sign away, it's pi over 6, not pi over 3.
Pi over 6. Pi over 6, yeah.
Not pi over 3?
No, because then you take the reference angle and then that's makes it negative.
What's the arc cosine of positive 1/2? It is pi over 3. The arc cosine. Cosine of what gives you 1/2? Cosine of pi over 3. So my angle in quadrant 2 is I'm going to take pi minus pi over 3. That happens. You were giving me the answer for sine. That is correct. I was pointing at the sine one? All right. So the moral of the story is when you're dealing with arc sine, having negatives out front is very easy. If I have a negative here, what happens? I just put a negative there. Arc sine is very easy to deal with. Arc cosine, not so easy. When I have negatives in front here, I don't just get to put a negative in front of my regular old answer. I've got to convert my angle into an angle in quadrant 2. Unfortunately. So arc cosine is harder to deal with than arc sine is.
So if it's negative, you have to get a negative answer.
If you're dealing with arc sine, if your input is negative, you'll get a negative answer.
Is that the same for cosine?
For arc cosine, if your input is negative, you will get a positive answer in quadrant 2.
Is that related to it being a positive or an even and odd function at all?
Yes, it's very related to it being an even and odd function. And again, it has everything to do with the graph. This graph of cosine is an even function, so that's why we couldn't use negative pi over 2 to pi over 2, because we'd have the reflection and it's not 1 to 1. So we had to pick a different interval. We had to pick 0 to pi. Where our sine was a nice odd function, so its symmetry is about the origin, so I can go minus pi over 2 to pi over 2 and still be 1 to 1. And it's very much like the odd properties, I agree. Our odd property was sine of negative x is negative sine x. Oops, you can't see what I just wrote there. Still can't see, gotta push the right button here. There it is. Since sine is odd, inverse sine is also odd. So the arc sine of negative x is negative arc sine of x. So if I have a negative pi over 6 here, I can just plug in pi over 6 and make my answer negative. Everything to do with evens and odds.
So the arc cosine of negative 1/2, did you do like we did before with negative 2, which we had to convert it because it's in quadrant 2?
Yeah, can you explain that
And
one?
then you know the reference angle.
Right, so what I do when I'm dealing with arc cosine, if this is negative,
Yeah.
I ignore the minus sign for a minute, and that gives me the reference angle. The reference angle is pi over 4. To convert to quadrant 2, you're always going to take 180 degrees, which is pi, and subtract the pi over 4. So you're going to take pi minus the reference angle. Same down here. With the arc cosine of the negative 1/2, I ignored the negative, which gave me pi over 3. And then to convert to quadrant 2, I take pi minus that reference angle. Give me a quadrant 2.
Okay.
Yep.